This is a video on the addition rule in probability. There's two major operators that are used when doing logic. One is an AND operator, one is an OR. So the addition rule goes with the OR operator. So these are compound events, which means there's some sort of combination of simple events, two or more of them, using the OR operator. So if I have the probability of A or B, I am indicating that in a single trial, what is the probability that A happens or B happens, or they both happen. Now, we have to be careful here because this deviates from how the word or is used in the English language. Usually when we use the word or, we don't mean both. However, in mathematics and logic, in order for it all to work out, A or B means either A or B or both. There's actually a logical term for what's the English OR, which we call XOR in mathematics, but we're not getting into that today. So for all intents and purposes in this course, if you hear OR, it means either or both. Okay, so the addition rule itself says that if I want to have the probability of A or B, this is going to be equal to the probability of A plus the probability of B minus the probability of A and B. Now this subtracting off is so that you don't get a double counting. So there are the AND operators poking in, okay? So we have to subtract off the conjunction, the AND, because otherwise we'll get a double counting. So let's take a look at an example of this and see if we can't put real numbers to this and make this rule make more sense. Okay, so we're going to build a two-way table. And we're going to say, okay, what if I have people, what if I'm doing a drug test? Okay, so we have a positive result, which means that the test indicates drug use, or we have a negative result, which the test indicates no drug use. And then we have over here two options. We either have someone who has used drugs, or we have someone who has not. So it is possible for there to be error in the test. So we're going to sample 1,000 people because it's a nice round number. And we're going to have 44 of those 1,000 used drugs and got a positive test result. So that means that the test got it right. They used drugs and they got a positive result. We have 6 that used drugs and got a negative test result. So this would be 6 false negatives. So these people used drugs, but the test said, nope, they did not. We have 90 people who did not use the drugs and got a positive result. So 90 out of 1,000 got a false positive. And 860 of the 1,000 people did not use drugs and got a negative result. All right, so what we're going to do is let A be that the subject used drugs, and B is going to be that they got a positive result. So we want the probability that the person used drugs or got a positive result. So if we look at this, the number of people who used drugs was 44 plus 6 out of 1,000, because that's the ones that used drugs got a positive, used drugs got a negative. The folks that got a positive result are this column, so that's 44 plus 90 out of 1,000 got the positive result. And then we want to subtract off the portion who used drugs and got the positive result. So that's this group here, used drugs and got the positive result, 44 out of 1,000. Now we have to subtract them, because if you look, we counted that 44 here, and then we counted them again there. So we have to subtract them off in the end. All right, so if you take a quick look at that, that's 44 and 6. That's 50. 44 and 90, that's like 134. 50 and 134 is 184, minus 44 is 140 out of 1,000 who either used drugs, got a positive result, or both. And because there's the both, that's that 44 people that we would have counted twice had we not subtracted off. So probability-wise, that's 0.14. So that's like 14% of the whole are either in category A, they're subject who use drugs, they're in category B, they got a positive result, or both. So it'd be 14% of the population. Okay, it's possible for two events to be what we call either disjoint, or sometimes this is called mutually exclusive. Two events are disjoint if they cannot possibly occur at the same time. Okay, so if the two events are disjoint, then our addition rule can be simplified. It can be the probability of A or B is equal to the probability of A plus the probability of B. So long as A and B can't happen at the same time, you just add the two probabilities. Okay, so let's try this. Let's let C be that subjects used drugs and got a positive result. And let's let D be that they did not use drugs and got a negative result. Okay, so these groups are mutually exclusive. You cannot be in either group because either you did use drugs or you did not. You either got a positive result or you got a negative result. There is no overlap between these groups. This is essentially the two groups that got true readings on the drug test. So we want to know what is the probability of being in either C or D, right? So being in C, there are 44 out of 1,000 people that used drugs and got a positive result. There are 860 people out of 1,000 who did not use drugs and got a negative result, which means that there's a total of 904 out of 1,000 people who either used drugs and got a positive result or did not use drugs and got a negative result, so who got a true test result, which is 90.4% of the time. Now, this of course means that this test gets it wrong about 9.6% of the time. Now, if you're like basing somebody's employment on this, or the safety of your workplace on that, that's probably not the best test in the world for this, given that it's almost getting it wrong 1 in 10 times. So just to kind of give you like real world, why would I ever care about this? It's a good quality assurance question. So in the end, the addition rule governs the or situation when we're calculating statistics. If it is not a mutually exclusive set, it's the probability of one event plus the probability of the other minus the probability of the and or the both. If it is a mutually exclusive set or two mutually exclusive events, you can leave this last part off and just take the sum of the two probabilities. All right, so that's the addition rule.